Okay, so what you have in terms of this green sheet of paper, so this is all you're doing, like the first one's pretty simple, it's just some generic equation, A is turning into 2B, you're producing 2C. You've got these concentrations are going to be doubled, you're just going to find the order of A, order of B, and the overall rate law. Then you're going to find the value of K. Now, when you get to C, what I'm saying here is that, okay, now that we know what this is, now I'm going to say, all right, hey, I'm going to give you these concentrations, then figure out what the rate is based upon your rate law. Pay attention to the units. So, that bottom one is the same way. Basically, you're reacting nitrogen monoxide with bromine gas, and you're making Novert, or Novert, however you want to say it. And it's the same process, find the units of K. On the white sheet, only do the ones that are circled. Okay? That's why I said this looks much worse than what it is. So, let me give you a hint on 19. So this is a decomposition reaction. Phosphorus trihydride is basically breaking into phosphorus and hydrogen gas. So over a specific time period, you have the concentration of PH3 is consumed in a 2-liter container. Each second reaction, what are the rates of production of P4 and H2 in this experiment? Okay, so with this one, okay, you're given some numbers. Remember, your molarity has to be in moles per liter. You're not given the molarity straight up. 19 is not what we've been doing because you don't have charts. This is going to be where you can either set it up as like the inverses of the coefficients and set them up as rates, or you can do the stoichiometry. But when you get to 21, okay, 21 is just, hey, do you understand how you're going to get the values of K? Do you understand how the units work? When you get to 23, 24, and 27, this is where you have concentrations and different reactions, and you're going to find the rates. Now, 27, don't flip out on 27. It's got micromoles per liter, because these are very, very, very small quantities because it's the amount of hemoglobin and the concentration of carbon monoxide. It's the same process, it's the same thing, just instead of moles per liter, it's micromoles per liter because you have such small quantities, but it's the same process. Okay, so the green sheet and the ones that are circled on the white sheet, and that's it. Yes, Mr. Jones?
What's meant by rate law?
Okay, so the rate law, if you look on back here, so the rate law is just what we've been talking about, where it's just R equals K, something like that. We'll get into the integrated rate law tomorrow. So the rate law would be just something like this, where you would say R equals K times concentration of A. That's the rate law.
You just write it out quick next one.
Yeah, okay. That's it. That's the rate law. Integrated rate law we'll deal with tomorrow. So rate law is just that simple thing. Okay, Mara, stop you on the camera, please.